Hi guys, my name is Mrs. Rona. I teach AP Physics on the west side. I'm here to talk to you a little bit about energy as an introduction. So you should have page 1 of your new packet out. It should say Introduction to Energy Notes. We're going to go through these together. Hope you enjoy the video. So we want to take a look at this example. So this would be kind of like a roller coaster problem. And so the question might say, at what height h would the 500 kilogram roller coaster car need to start at so that it just barely makes it through the loop of radius r equals 5 meters, assuming the track is frictionless? So there's a lot of physics going on here. How is this motion down the ramp different from what we've seen before? Well, there's a couple ways that this is a little bit different. The angle isn't constant, so this isn't just an incline, right, that we saw in Unit 2. This is a curvy track, so the acceleration would no longer be constant. How is the motion in the loop different from what we've seen before? Well, last unit we did uniform circular motion. So the question becomes, while it's going through this loop, will the roller coaster go at a constant speed? And then we want to know, do our models that describe motion, so kinematic equations, Newton's laws, circular motion equations, can we accurately describe this motion using what we know from units 1, 2, and 3? And unfortunately, the answer is no. It has a changing acceleration, and as it goes through the loop, it's going to slow down and speed up, so it's not uniform circular motion, and therefore we need a new way to describe and predict this motion. That brings us to energy. So Unit 4 is all about energy. So what is energy? What are we going to talk about? What is our kind of base definition of energy? So we're going to say energy is a stored, conserved, substance-like scalar quantity. So scalar is important. When objects have it, they have the ability to cause change. And we'll talk a little bit more about what that exactly means. But you want to have this definition down at the top of page 1. You can pause this video if you need to write that down. The units for energy are a Newton times a meter, so 1 Newton times 1 meter. And if we break down what a Newton is, we know a Newton's a kilogram times a meter per second squared times a meter, and then if we put it all together, we get kilograms meters squared per second squared. That's a mouthful, so of course scientists came up with a better way of simplifying the units for energy, and it is joules, okay? J is the symbol for joule, and you've probably seen this before in chemistry, but we're going to measure energy in joules. So we talked about energy being something that can cause change. When objects have it, they can cause change. So we're going to talk about a bowling ball. How could a bowling ball cause change? So in this picture, we have students standing on a table, dropping a bowling ball into a box full of paper. The bowling ball at this picture is held above at a height or a position above the ground. It can cause change because it can be dropped. Therefore, energy is being stored in the bowling ball due to its position above the ground. There's other ways that a bowling ball can cause change. So how could this bowling ball cause change? Well, this bowling ball is rolling down the bowling alley. It's rolling along the floor. It can cause change because it can smash into things. Therefore, energy is being stored in it as it travels down the bowling alley. Another way we could have a bowling ball causing change is if we compressed a bowling ball. So if we compressed a bowling ball, and I'll show you a video of this bowling ball being compressed in a second, it can cause change because when released, it can expand and push things out. Or in this video I'm going to show you just for fun, it could just explode, and therefore energy is definitely being stored because it can cause change to objects nearby. So let's take a look at that video of the bowling ball exploding. Start it over.
And here we go.
This is a hydraulic press pushing down on a bowling ball. There you go. When you press down on a bowling ball, it has the ability to cause change by either being released, expanding, or just causing an explosion. One other way would be if a bowling ball were heated up. So if you had a really hot bowling ball, it can cause change because it can heat up other objects through contact. Therefore, energy is being stored in it if it is really hot. Okay, so we've talked about a few ways that energy can cause changes because of the energy being stored in it. So let's take a look back at page 1 on classifying energy storage modes. So we've got a couple different ways that we classify energy. First one we're going to call potential energy. So potential energy is energy stored due to an object's position. So thinking back to those bowling ball examples, the first one was the bowling ball being held above the floor. there was energy stored due to the fact that it was raised above the ground. So that would be considered one type of potential energy. Another one would be when we compress the bowling ball. So compressing it was we changed its position, and so we stored energy due to its position. The second way we can classify energy, how it can be stored, is going to be kinetic energy. So kinetic energy is energy stored due to an object's motion. So that would be the bowling ball rolling down the bowling alley. It is in motion, it has the ability to cause change, so it is storing its energy kinetically, we would say. It has kinetic energy. And the last one is mechanical energy. And mechanical energy is simply the sum of the potential energy and the kinetic energy. So if you look at how much potential you have, how much kinetic you have, and add those two together, you can know how much mechanical energy is stored in your object or your system. So let's talk through the different energy storage modes. K is what we're going to call kinetic energy. So that would be energy stored kinetically. The best example we've talked about so far is the bowling ball rolling down the bowling alley. So it would be an object in motion. Second one we're going to talk about is capital U lowercase g. So we're going to use this capital U to represent any sort of potential energy that's stored. So UG is potential energy stored gravitationally. So this would be any object in a gravitational field. So if it's near the surface of Earth, near any other object that's causing a gravitational field, it can have energy stored gravitationally. And we'll talk a little bit more about the systems tomorrow, but this is one way you can store energy. Third way we're going to talk about is US. So this is going to be potential energy stored in a spring. So we would say energy stored elastically. So that would be the bowling ball being compressed. The most common examples we'll see about these are springs or rubber bands or anything that has the ability to kind of compress or stretch and store energy in that way. The next one is EChem. So this is chemical energy that is stored within a system. So you can think about this being stored in bonds within molecules, or if you think about, how would I have energy stored within my body? Well, I have chemical energy stored in my body. I ate breakfast this morning, and so I have energy stored chemically within the molecular bonds in my body. Last one we're going to talk about is etherm, and this would be energy that is stored thermally within a system. So this would be something like the heat of an object. It could be warmed up due to friction. That would be thermal energy, and most likely we'll see it in the form of heat. So these are the 5 main ways we're going to talk about the ways energy can be stored. Why do we care about how energy is stored? That's the law of conservation of energy. So you've heard this before, I'm sure, in a science class or somewhere before. But energy cannot be created or destroyed. It can only be transformed, meaning it goes from one storage mode to another, or transferred to a different object or system. So we can talk about energy being transformed as that bowling ball was dropped. At first it had gravitational potential energy due to its position above the ground. If it were dropped, as it starts to fall, some of that energy would be transformed into kinetic energy. Once it hits the ground, it could transfer that energy to another object, to the box, to the ground, to the paper, things nearby, to another system. But no matter what, the energy doesn't go away. It's either transformed or transferred. And this is going to be one of the big tenets of our unit. Where did the energy go? What was it transformed into another storage mode of energy, or was it transferred to another object? All right, thanks for watching. Have a great day.